Third grade builder number 59. We're going to add 233 plus 67. In the ones place we add 3 plus 7, and that makes 10. Then 6, 7, 8, 9, and one more makes 10. And 2 plus 1 is 3. So we get a sum of 300. Now we're going to subtract 800 minus 38. Starting in the ones, we have more on the floor. So we go next door. Nobody's home, so I'm going to go over to my 8. Take one of those hundreds and turn it into 10 tens. Now I still can't do 0 minus 8, so I go next door. We've got 10 over here, so I take one of those. Now I have 9. And the 10 that I took from here, I am regrouping and turning it into 10 ones. So 10 minus 8 is 2. 9 minus 3 is 6. And 7 minus nothing is 7. Our difference is 762. Now we're going to multiply 70 times 7. We start by multiplying 7 times 0, and that's 0. And then 7 times 7, which equals 49. So our product is 490. And we have 7 stacks here. 7 times 9 is 63. 7 times 2 is 14. 7 times 5 is 35. 7 times 3 is 21. 7 times 8 is 56. 7 times 4 is 28. 7 times 7 is 49. 7 times 1 is 7. 7 times 6 is 42. And 10 times 7 is 70. On our composite figures, we're finding the area of the entire shape, and we're breaking it apart into 2 smaller rectangles. We're going to start with the not shaded part over here. To find area, we multiply length times width. So we have a side here that is 1, 2, 3, 4, 5, 6, 7 units long. And this side is 1, 2, 3, 4 units long. To find the area, we just multiply 7 times 4 because we have 7 rows of 4. And 7 times 4 is 28. So we have 28 square units here. And on our shaded part, we have a side that is 1, 2, 3, 4, 5 units long. And we have this side that's 1, 2, 3 units long. We're multiplying length times width. So we could multiply 5 times 3 or 3 times 5. Either way. Because we have 5 rows of 3. And 5 times 3 is 15. So now we're going to add 28 plus 15. I'll try to do it mentally here instead of rewriting it up and down. 28, if I add the 10, that would be 38, and then I'm going to add 5 more, 39, 40, 41, 42, 43. So I get a total of 43 square units. If I counted up every one of these squares, there are 43 of them. Okay, in our capacity and weight section right here, starting with milliliter, a milliliter is a unit of liquid volume, and it's a metric unit. A fluid ounce is liquid volume, and that's a customary unit. A gallon, like a gallon of milk or a gallon of gas, is liquid volume, and that's a customary unit. A kiloliter is also liquid volume, but it is a metric unit. All of the ones here that end with the liter are metric. A pint is liquid volume, and it's customary. A pound is not liquid. We use pound when we are measuring weight, and that's a customary unit. A liter, like a 3 liter of Coke, is liquid volume, and that's a metric unit. Ton is a unit of weight. It weighs a ton, like an elephant. It's 2,000 pounds. That's a customary unit. An ounce, not a fluid ounce, but just an ounce, is a unit of weight, and that's a customary unit. A cup is liquid volume, like a cup of coffee, and that's a customary unit. And a quart is also liquid volume, and it's a customary unit. In our geometric figures, this shape right here has one pair of parallel sides, but these two sides would not be parallel because they would cross each other if they kept going. So if it has one pair of parallel sides, it's called a trapezoid. Our attributes, we have all four sides are congruent. Well, no, this side and this side are congruent to each other, but this one's short and this one's a different length. These little tick marks on the side, these little marks, are put there to tell me that they are the same or different. So if they both have one line, then they're the same. This one has two lines, so it's a different size. There's nothing else with two lines on it. And this one has three, so it's a totally different length as well. So number one's not true. Two pairs of congruent sides. And we already said there's only one pair, so that's not true. One pair of parallel sides, and parallel means they don't cross. So this side and this side would be parallel. That's true. All four congruent square corners. There are no square corners on this shape. In our fraction section, we are supposed to shade and then put the comparison symbol in. Now you can really shade the 1/5 and the 1/6. You can shade 1 out of 5 anywhere in here. I like to shade at the bottom though because it's a little easier to compare. So 1/5, I'm going to shade this 1/5 piece. And then over here I'm going to shade this 1/6 piece. And now I'm comparing those two. And they're pretty close, but this piece is a little bit bigger than this piece. So the 1/5 is greater than 1/6. On our number line that we are going to mark with 1/6 and 1/3, the line from 0 to 1, we have divided it along the top part. We've divided it into 3 sections, so we call those thirds. We start at 0 and we travel this far. We've gone 1/3 of the way, 1 out of 3 parts. And then we keep going. We've gone 2/3, or 2 out of the 3 parts. And then if I keep going here, I've gone 3 out of 3 parts, 3/3, which is the same as 1 whole, because it's the entire line. Along the bottom, we have 1, 2, 3, 4, 5, 6 parts. So that means the line has been cut into 6 pieces, or 1/6. So we've gone 1/6, 1 out of 6 parts, 2/6, 3/6, 4/6, 5/6, and 6/6. 6 out of 6 parts, which is the entire line here, one whole line. On our vocabulary, a mathematical sentence where one side is not equal to the other side is called an inequality. The point or corner in a geometric figure is called a vertex. If there are more than one, we call them vertices. Describes how much something holds is its capacity. equal measure, same shape, same size. That is congruent. And how heavy something is its weight.